On our staff, as well as one of our mentors. So he does courses for us, teaches courses for us as well as Alex, who is on our staff and is going to be supporting our course tonight as well. And they'll tell you a little bit more about themselves, a little bit about their work as professional developers. A couple of housekeeping rules as we get started tonight. If you would keep your device on mute unless your instructor asks you to come off and join in on the conversation. Of course, we love to see your smiling faces. So if you'd like to be on camera, we'd love for you to do so. But keep in mind, as you just heard our little voice say, that we are recording and we will be posting or may post on our social media channel. So just a heads up there, if you're not comfortable with that, please feel free to keep cameras off. I'll be hanging out for a little bit, monitoring the chat as well for any questions that you may have as we go along. But of course, those will be directed towards your instructor, Caleb, and support it, Alex, tonight as well. But again, thank you so much for being here. Hope that you really enjoy your course and you come back for another course with us or for another event that we have at SC Codes. So with that, I'm going to turn it over to Caleb and then Alex as well for them to jump in, give a little bit of background, and then you guys are on your way with Ruby. So thanks again for joining us tonight.
Thank you so much, Morgan. As Morgan said, I am Caleb Mcquade. We'll be going through some Ruby concepts tonight, and I'll talk a little bit more about our platform and what the concepts level class means for us in just a little bit. I am Caleb Mcquade. I live in Greenville, South Carolina. I've been in the tech industry for about 2.5 years now. I was actually in finance before moving into tech, went to a boot camp here in town, and ended up in Charleston for a little bit, doing some work for a company called Booz Allen Hamilton. But I'm back with a company called Enoch Collective in Greenville, South Carolina. And we're an agency and we do custom software for different people. I am a married man of almost 5 years now and a new father as of about 2 weeks ago. And we've got our newest learner here, and this is Haley Wren. And she is just the sweetest, and she's, whoops, sorry. She's also already got her hello world there. And she is just super excited to learn Ruby with us tonight. Unfortunately, I think she'll be sleeping through most of it. Yeah, so if you hear anything crazy, that is her. And if I stumble over my words or just fall asleep on you, that would also be her as well. Yeah, so that's me at a snapshot. I will pass over to Alex, who's going to be supporting us tonight.
Yeah, hey everybody. Hey Haley, hey Caleb. Thanks for the introduction there. I am Alex Martin. I'm based out of Greenville, South Carolina as well, and I'm the tech lead for SC Codes, which means I handle a lot of our technical platform, some of our curriculum decisions, that sort of thing. Tonight, I'm just here for support. Caleb's going to be lead instructor, so I may be kind of on and off camera, but I'll be keeping an eye on chat. So if you have any questions, feel free to drop those down there. And if there are any really big, complicated questions or we have lots of stuff come up, then Caleb and I may kind of ping pong some of our experience. I'm also a career changer. I came from a medical background, so I worked in hospitals and with patients at different levels until I changed about 7 years ago. And I've been doing this full-time professionally since then, remote, on site, lots of cool different stuff. So if you have questions later in the evening about career path and options, we've both got some really neat experience to share. But thank you all for coming out. We're really glad you're here.
Thanks so much, Alex. So let's hop in. I'm going to share my screen here. And welcome, as we said. Thanks for spending a couple hours with us tonight. We're going to be going over the language of Ruby, and I'll talk about that in just a little bit. But we'll talk about SC Codes first. And SC Codes is a partnership with the South Carolina Department of Commerce. There's a big need for tech work in general, especially in South Carolina. And SC Codes is interested in trying to fill that gap. And we are a free resource and a platform to help South Carolinians learn how to code, skill up, maybe, introduce a refresher or something like that. But if you are to go to sccodes.org and go to the courses page, yours will probably look a little bit different than mine. Yeah, sorry, we'll hop into our library here. And you won't see all of these, but specifically I want to talk about our backend certification pathway. And we offer front-end and back-end courses on our platform today. And we'll talk more about that in a little bit as well. But Ruby is a back-end language. So Ruby handles a lot of the data management and kind of distributing data from the database. So it kind of maps things and tells the data where to go and what to do once we have that data. And we have kind of 3 levels of courses at SE Codes. We have a concepts level course, which is your beginner level, basics, which is intermediate, and then our applications level courses, which are our advanced courses. So our beginner level courses are for everyone. You do not have to have any experience writing code or even open a terminal in your entire life. You are welcome to hop into our Ruby concepts course. Next is our basics. This will take you a little bit longer, and this will kind of be somewhat dependent on the Ruby concepts. If you already know a little bit about Ruby, basics might be for you. And then Ruby on Rails is kind of our highest level of backend course at this point. And this will take you through building real world applications and things that you can put on your resume, on your portfolio site, and say, hey, I know how to build real life applications with Ruby. Another pathway that we have right now is our front end certification pathway. And this deals mainly with JavaScript, but it's the same structure. So we start you off with very basic JavaScript concepts. We take you through some HTML and CSS in our basics course. And then we give you an experience with React, which is kind of a different flavor of JavaScript. But same structure, same outline, front end and back end. So what can you expect from tonight? We'll run about somewhere between 2 to 3 hours, somewhere in that 2.5 hour range. But this will be a lot of group lecture time. So it'll be a lot of me talking, unfortunately, but that does not mean that you all cannot be involved. So if you all have questions about something, we'll have dedicated question time. But if you have just a burning question that you have to have answered, please feel free to come off mute or throw the question in the chat and Alex will be monitoring there. We'll walk through some outside examples and some problems just to show you how things work and how things react when we play with things. Ultimately, this is your time. So if you've gone through these courses or if you have questions, please feel free to hop in, get those questions answered, whether it be about Ruby or just the tech industry in general. We'll talk about some of that at the end. So what do I expect from you is just to ask a lot of questions, as I've said, questions. And then just to stay involved, be curious, get involved if you feel led with SE Codes. We'll have some links to our Slack channel and other places where you can further your learning and get more help later on. A quick look at our syllabus for tonight. We've got kind of an introduction to Ruby, kind of the history of it, where it came from, what it does. We'll talk about the variables and assignments in Ruby. And these are, a lot of these concepts tonight are concepts that can be applied to a lot of different programming languages across the spectrum. So a lot of these concepts apply to JavaScript, and to C and C# and just a ton of different languages. Data and operations. So we need to do things to our variables and our assignments. So we'll talk about what the most common data types are in Ruby and how we do things to them, and how we do different operations on them. Talk about arrays, which are large data sets of different data types. Talk about conditionals, which are essentially just like if-else trees. Blocks, which are essentially the functions of Ruby. And then every now and then we'll hop into an assessment, and these are not graded. So, and these will be kind of extra if we have time. Another thing I forgot to mention, we will take probably about a 10-minute break around the top of the hour, just so that everyone can kind of take a break, stretch their legs, go get some food or something like that. And also so that I can rest my voice. So let's hop into internet basics. And you've already heard me talk a little bit about front end and back end. And you might say, you know, what does that exactly mean? So if you were to go to sccodes.org right now, you would see this lovely website. And it's got a purple banner at the top. It's got this nice deep navy banner right here, and you can click buttons and it'll take you different places and all kinds of good stuff there. This is the front end of the website. You can think of the visual side of the internet as the front end. These are things that are going to be loaded on your device most of the time. And a lot of these, a lot of the front end languages deal with more design, more so than the back end language. And they deal with user interaction. With back end programming languages, they deal with the things that are not immediately apparent on the website. So when I log in here, and I go to this login page, sccodes, well, it's gonna act as if I'm already logged in here. But if you go to any login page and you type in your username and your password, you are sending that information to the backend. And the backend is going to run that information through the backend server, and it's going to say, you know, hey, does this username and password match up to something in the database, some kind of user, some kind of person that has logged in before. And if it matches, great, you'll get this landing page here and you're logged in and you're able to do whatever you need to. If you're not logged in, if it can't find your user, then it's going to say, sorry, you made a mistake, or maybe you're not signed in or something like that. But that's more of the back-end side of things. The back-end deals with a lot of data and data management. Let's go to an image here. So let's say you pull up Facebook and you want to see the latest pictures from your friend's vacation. On your computer right here, you type in facebook.com and you navigate to your friend's page, and then you click on their images. When you click on their images, your client over here sends a request to a server, which is essentially just a special computer somewhere in the United States or maybe even overseas. And that server interprets your request, and then it's going to send over those images as code. And it's does this all incredibly fast in milliseconds. But it sends it back to your computer as code. And this right here is considered the front end, your client. And the back end is what is going to be sending that code after it gets the request from the front end. So tonight we're going to be spending our time over here in the server land, in the backend land of programming. If you have done anything with JavaScript or HTML and CSS, you've done things over here on the front end. with probably JavaScript. So what is Ruby? Ruby is a backend programming language. There are a myriad of different other backend programming languages. If you're familiar with backend programming languages, you may have heard of Java or Python, very popular ones, and even C, C#, C++. And then JavaScript even has a backend programming language as well, a backend version, and it calls itself Node.js. It was developed in 1995 by a man who is commonly referred to as Mats. His last name is Matsumoto, so everyone just kind of shortens it to Mats. But he specifically wrote Ruby to be very developer friendly. So you'll see things sometimes in other languages that are confusing, and you might say, why do they do it this way? This makes no sense. As a developer, it makes no sense. And Mats kind of took that and said, how about we try and clean up a lot of these issues that developers are having with programming languages? And he wrote Ruby. Ruby is a language that resembles some other languages, specifically a language called Smalltalk. Yeah, just very developer friendly was the idea for Ruby. It is an object-oriented language, which means that everything in Ruby, at the very core of those pieces, everything is an object. Yeah, if you're looking for object-oriented programming or object-oriented language, Ruby is one of those. It's not as popular as it once was. It used to be extremely popular, especially the framework Ruby on Rails, because anyone could just pick up and just write basically a production level application in just a few minutes. There was very little setup, very little that you had to know to get started. Very popular at the end of the 2000s, early aughts, and it's used by some big names, I believe, even today. If you've ever used Shopify, Ruby is used by Shopify. I believe that Twitter was originally started with Ruby on Rails. Maybe even Airbnb. I don't know if they still use it, but I believe they started out with Ruby on Rails. So I've been saying Ruby, I've been saying Ruby on Rails. They are not the same. Ruby on Rails is a framework, which is essentially, I believe Alex likes to say, it's a toolbox of sorts, to where you can open it up and you can do very special, cool things with the tools in that toolbox that don't come baked in with Ruby. But Ruby on Rails uses Ruby as its base language. Anything to add there, Alex?
Yeah, so this is a really good time to answer a couple questions that came through in chat. The first one Caleb already kind of broached on, but he mentioned some different backend languages. And Jill asked earlier specifically about Python and Java, why we might use Ruby over something like Java or Python, or even, to Caleb's point, C. And we'll talk a little more about this as the course goes on tonight, but each language can do the same things. There is no particular language that magically has more or less ability than another, because they all run on the same computer, right? They all run on the same devices. Ruby is known for being a very friendly language. Mats has been quoted as saying that he wrote it for developer delight. It's meant to be fun to write. It's meant to be easy to read. There are trade-offs to that. As a result of it being really easy to write, sometimes it's not maybe as performant as another language. So if you need something at a really large scale, you may choose to take on Java, because Java, while it's not very much fun to write, is really, really good at large scale operations. To build a little bit on something Caleb said about Twitter, Twitter was originally built as a Ruby on Rails application because it was fun to write. It was fast. It would, you could get an app going really quickly. You'll learn a little more about why Ruby is that friendly as we go on. But once Twitter reached a certain number of users, Ruby started kind of getting slow because it's not really built to work at that level. And so at that point, Twitter started hiring Java engineers and saying, okay, we need to build Java applications to replace some of these older Ruby pieces. Now, that was when Twitter was a multi-billion-dollar business. That's not like they got their first 100 users and it fell over. But it is something where the languages you use are kind of specific to the case that you're in. For these early sorts of lessons, the languages are interchangeable. You could learn Ruby or Java or Python at this point, and you're going to be working at the same kind of scale. But as you learn more about this stuff, you'll start thinking about business needs and when a language might be the right tool. And that's when you're starting to think about really large scale decisions, more like what we'd call a software architect than really an engineering decision. Jill, does that help answer your question?
Yes.
Awesome.
I will also say, go ahead.
Yeah, no, go for it, Caleb.
I was just going to hop in and say, I did Ruby in my boot camp, and I've done it a little bit of stuff since then, but Alex is our Ruby expert tonight. I have some experience, but he's our guru for tonight.
So there's one other question in chat from Mike, and he asked, what's an object in this context? Caleb, do you want to take that one?
Ooh, I was going to throw it to you, but I can try and hop in here. So if you're familiar with other languages, there is the concept of an object as something that represents a whole item that has several different elements to it. So later on, we'll talk about kind of a dog object. So a dog might have a name and a breed, and whether or not they were a rescue or not, and a color, and all kinds of different elements to that dog. And then, so you might build an object that allows for multiple dogs with multiple different names and breeds and things like that. In the context of a Ruby object, I am actually going to throw it over to Alex for this one.
Yeah, totally. So no, what Caleb's describing is exactly right. And that's what we mean when we say object-oriented. If we go back to that concept that everything runs on the same type of device, it runs on a computer, it runs on a processor. Your computer processor, whether that's in your laptop or your desktop or your cell phone, doesn't know what a dog is. It doesn't know what a car is. It doesn't have a concept of objects as spatial things that we think of like as people, right? If I pick up this pen is an object to me. To the computer, this is some pixels on a screen that's being processed. It's electrical signals, it's ones and zeros. Object-oriented languages are a relatively new invention because in the early days of programming, when we had punch cards and really simple instruction sets, programming was literally instructions to the computer. Add these numbers, do this operation into the program. That was a whole piece of software. Today, we're doing much more complicated behavior. And as humans interacting with the computer, we need a way to talk to the machine that we understand and that the machine can interpret. And so if I want to have a pen in maybe a video game I'm making, I can create in an object-oriented language a pen. And it's actually a class or an object called pen. I can give that object properties. So in this case, it has black ink. It's a few inches long. The cap is off. All of those are properties of this pen. And I can write code that reads just like that. So I might say pen.ink color. I might say pen.length. And that's what object-oriented really means, is somebody took the time to build this language in a way that we can communicate with it the same way we'd communicate with other people. And we don't really feel like we're talking to a machine as much as we're building this world inside the computer using these representative objects. Does that help, Mike?
Very much so. You've made it very clear. I appreciate it.
Yeah.
Awesome. Great questions, everyone. This is fantastic. Keep them coming. So we've talked a little bit about the history of Ruby, and now we're going to talk a little bit about what it does. And we've said several times that it handles data, and typically there will be some kind of database connected to Ruby. And a database is essentially just, think of a special Excel spreadsheet to where it holds information in different cells, and you can do different things with different types of databases that you wouldn't be able to do in Excel. But Ruby is going to be typically hooked up to one of these databases. Now, Ruby is going to be performing the actions of creating information to put into these cells, reading information out of these cells, updating information, and deleting information. And this is typically what we call our CRUD functions. And that's just an acronym that stands for create, read, update, and delete. And you'll see these across all backend programming languages. But these, essentially, you can do pretty much anything with data with these 4 actions. So if we took an example of like an e-commerce site, let's say we have a site where we make and sell our own jewelry. If we have a site, we're going to need to create a new set of earrings. We're going to need to, list out our whatever we currently have in our inventory. We need to update a price or a size for those earrings, and occasionally we might run out of them and we'll need to delete them. So if you just remember CRUD, you can do pretty much anything with data on the internet and with Ruby. Something kind of unique about Ruby and a lot of programming languages is that Ruby has versions to it. So if you have an app on your phone, you might see a list of 3 numbers, and they're separated by periods. And those numbers could be 0.0.1 or 1.0.2 or something like that. And that is the version of the app or the software. And Ruby has the same idea to it. And as computers get faster, as processors get better, sometimes you can add things to your software or your programming language, and Ruby does the exact same thing. So as Ruby gets better over the years, things are added to it, and versions change. With JavaScript, this is not an issue, and JavaScript doesn't really have versions in the same way that Ruby does. Currently, as you can see up here, we are on Ruby 2.7.0 in this website. I believe if we go, let's see here. So Ruby 3.0 has been released, and that's kind of what we call a major version. If we go to this website right here, I believe we can take a look at all of the Ruby versions so far. Yeah, so 2.7 is pretty recent, but 3.0 is slightly newer. So this might have some more features to it, but it also might have what's called deprecations. And deprecations means that there may be some things in the Ruby language or some ways that you might do things that are updated as things improve, as things go along, just to improve the developer experience. Just something to be aware of, not something that you have to deal with all the time. So let's talk about some tools for learning Ruby and tools for using Ruby in your everyday life. A lot of programming languages will have the idea of printing something to the console. If you're coming from JavaScript land, console.log is something that a lot of people use on a very consistent basis. Just kind of check your code and a way to force some kind of output to your terminal or to your website to make sure that you're in the right place. It's kind of like a GPS of sorts. Just you open it up, see like, am I going the right way? Am I at the place where I think I'm supposed to be at this point in time? So that's console.log, and that is for JavaScript. Ruby has the same idea with puts and print. So if I hop over to REPL over here, we've got a line of code that just says puts and then a string of hello world. And if I click run right here, we should see something over here, and we see the string hello world. So this is just going to print something to your console. So instead of puts, we can substitute print right here, and we get the exact same thing. The difference between puts and prints is, if you can see this, let's run that again. There's a little new line character right here. With print, there is no new line after it prints it out. With puts, whoops, it will automatically insert a new line after your put statement. Typically, I will use puts. I don't really use print, just because it's cleaner. It allows me to see a lot of things at the same time. So if I say puts, oops, hello class. So I've got two put statements here. It's going to put each of them on different lines right here. So that is puts and prints. That is really helpful when learning to code. The website that I'm using over here is called REPL. I think it's just called Replit. I think at one point the website was repl.it. See here. Yeah, it's replit.com. But this is essentially a way for anyone with access to the internet to write Ruby. So this means that you don't have to download the latest version. You don't have to configure your computer to make sure that you have all the right setup and all that stuff. You can literally just go to replit.com, sign up for an account, and then hop into the Ruby online editor, and you can get to writing Ruby right here. So if you're interested in following along, you just go to replit.com/languages/Ruby, which I will post right here. You actually don't need an account if you go to that link right there. But everyone is welcome to follow along tonight if you're interested. One thing that's unique about, or somewhat unique about Ruby, is that you need to make sure that it's installed on your computer if you're going to do a lot of Ruby development. If you've taken our JavaScript classes, we can just kind of pop open a browser and start writing JavaScript inside our browser or inside our terminal. And with Ruby, you can't do that. These websites allow for much easier access to it. But with Ruby, you have to download it onto your computer for it to run. So for computers that don't allow that, like Chromebooks, or if you're on an iPad or an iPhone, where it's more difficult to download things, these online editors are going to be real nice for you. Jill asked, can you explain compiler and installing versus using Replit? So a compiler, what a great question. A compiler is something that takes all of your code and it kind of breaks it down into computer readable code. So it just compiles it all together, and then it will run all of those things at the same time. And if you can see, we have this line here, bundle exec ruby main.rb. This is the command that compiles our Ruby code so that the computer can understand it, read it, and then print out what is supposed to happen for it. If it can't compile, it will throw some kind of error. So if we forget a closing, not apostrophe, quotation mark on the end of here, it should give us some kind of error where it says unterminated string meets end of file, and it will say, hey, you forgot something right here. And it's going to exit that compile command right here. So it doesn't compile, but it just says, hey, you have an error right here. We weren't able to finish compiling. Fix it and come back to us. Whoops. So if we do that, just go boom, and we're back to compiled. Alex, any other things to say about compiling Ruby?
No, I think that's a good explanation. I'll kind of speak to the installing piece, because that can be really confusing, right? Like, if I can run it on my computer, why do I have to install something? The issue is what runs on your computer, the things that run on your machine, are pretty limited. You know, there's lots of programming languages. We mentioned Python and Java and Ruby, but if you ever go look up a list, there are thousands of different programming languages. Your computer, depending on which type of computer it is, what type of device it is, doesn't need all those thousands of programming languages. It needs the languages that the operating system, so like Windows or Mac, was written in. It needs a few languages that are really common, that are used to support different things. But ultimately, if you had to install thousands of programming languages on every device, you'd have no space left on the device. You'd be able to take like one picture on your iPhone and boom, you're done. So what we've done with compilation, with compiling, is we've said, hey, on a machine that I'm writing Ruby in, I want to be able to download everything I need to know about Ruby, install that on this one machine, and then be able to save my Ruby application in a way that I can share it to other computers, and they don't have to have Ruby installed. So if you think about, and this is maybe a little archaic at this point, really, if you think about installing like a video game or a piece of software off of a CD, what's on that CD is not all the programming languages that were used to write the application. What's on that CD is a compiled, what's called a binary. It's a compiled file that will run on your machine, but was built on another computer that had all those languages installed. So the nice thing is, during that compile process, we can pull things out we don't need, we can clean things up, we can compress them and make them smaller, and we can give you this nice compiled file. The advantage to using REPL or Replit is you don't have to install, and you have access to all those languages right away. They're right there in your browser. And what's happening is whenever Caleb types in code and hits run, his code is being sent way across, just like that first picture we saw, all the way over to a data center in Virginia or California or Texas or somewhere else. His code is being sent over. It's being processed by a computer that has Ruby installed. And then Replit is sending back the output, sending the response back to you. So you don't have to install anything. You don't have to have a machine that's compatible with the complexities of building a Ruby app. You can just send it off to Texas and get it back using Replit. And that's, excuse me, that's the real strength, is there's no concern about compatibility, especially coming from, I grew up on Windows, and Windows, there's a new version every couple of years, and it breaks things, and games stop working, and software needs to be updated. Using the magic of the internet, we don't have to worry about a lot of that anymore. You can use a tool like this, and it'll work no matter what device you're on, because that server you're sending your data to out in Texas is going to run every time. And all it's doing is sending back the output. It's sending back that text. So that's why we kind of point out that if you're doing a lot of Ruby work, you might want to install it. But while you're learning and you're building really simple apps, you can do it right in your web browser. And that way you don't have to put anything on your computer and worry about that compatibility.
Thanks, Alex. That's an awesome explanation. Jill said, so this is kind of like giving the operating system like a dictionary to read what you wrote. And I think that's an excellent example. I can write Ruby code all day on my machine, but if I don't have the language Ruby downloaded on my computer is going to go, that's great, but I don't know what to do with that. But once I download it, it kind of gives my computer the language to interpret what I wrote and to perform the proper interactions. Again, great questions. These are awesome. So with every programming language, there's going to be some kind of documentation out there. Hopefully it's good documentation. And I feel like with Ruby and Ruby on Rails, we have some of the best programming documentation out there. RubyAPI.org is a pretty good website to look up methods and different commands that you might need with Ruby. Another website that all programmers should be familiar with is stackoverflow.com. That is just the place for programmers to get their questions answered. Ruby was once one of the most popular languages out there, so a lot of people asked a lot of questions about Stack Overflow. It rarely lets me down. And then if you know what to type into Google, you will also almost always get a great result back and a pretty good or pretty close answer to what you're looking for. So as you're learning, we don't know everything. We know a very small fraction of all there is to know about programming and Ruby. So feel free to look things up and to learn that way. Comments in code. Sometimes things can get real confusing real quick, and it can be easy to kind of lose your place a little bit, kind of forget what you're doing or why you wrote a certain something. Sometimes it's good to leave a note for yourself when you're done for the day, so that when you pick back up tomorrow, you remember your thought process and you don't have to start from zero. And that's where comments come in. And comments can be put right into your code. And there are different ways to do that in different programming languages. But with Ruby, all you need is a hashtag symbol or pound sign at the start of your line. And then that kind of indicates to the compiler that don't compile this line. This is just for the developer. This is just for the person reading and writing the code. So I can say, this is a comment, and this won't be submitted to the compiler. This is just for me. So I could even put some valid Ruby on this line right here. I could say, puts hello Ruby class. So that's valid Ruby, but it's not going to show up in my output over here. We've talked a lot about the command line. And with backend programming languages, you'll be spending a lot of time in your terminal or in your command line. And those are kind of interchangeable ideas. What we're doing over here is we're running things in our terminal or on our command line. And Ruby has something built in called IRB, which stands for Interactive Ruby. And this allows you to open a Ruby environment just directly inside your terminal. So this is an application that I have running on my computer. I'm gonna put this over here. Do not want to update. But this is just my terminal that I have. And I have Ruby downloaded on my machine. But if I were to just type IRB, it immediately puts me into a Ruby environment. And this is the same thing that you would get when running Replit on your browser. So this is just kind of extra, but IRB allows me to write Ruby puts hello class, and then it immediately runs it once I hit enter there. So it returns hello class, and then I also get a return of nil. And this just allows for immediate Ruby testing and development directly inside your terminal. So you don't have to, boot things up or anything like that. If you want to try out IRB specifically, this link right here is essentially what we're doing in Replit, but it's just another cool little thing that somebody built. I believe it's Josh Nuss. But you can write in IRB right in your browser. You get the same thing. All righty. We are at 6:50-ish. Does anyone have any questions so far? Mike said, is there a preferred text editor? So because this is a basics course, we will typically send people directly to kind of an online text editor. And as you can see with Replit, we have our terminal on the right here, but on the left here, we have just a plain text editor. And we are interested in having as many people as possible able to use our course, and we don't want any barriers to entry. So that's why we point people to online resources. If you're really into Ruby, if you're really into programming in general and want to start downloading some of those text editors and those kind of cool tools, I use VS Code, but everyone has an opinion, and that's just one of those things that if it works well for you, that's awesome. But I use a program called VS Code. All righty. We are going to take about a 10-minute break. If you are interested in doing something over the next 10 minutes, I would hop on to secodes.org, hop into our Ruby Concepts course, and just look into variables and assignment. And that's what we're going to be talking about next. But I will see you all right around 7 o'clock, 7:01, something like that. All right, everyone. Before we get kicked off too much, did anyone think of any questions or anything during the break about the things that we've talked about already? Yes, I agree with Jill that coffee at 7 is not the weirdest thing that I've done with a newborn. I'll tell you that. Yeah, it's like 3 a.m. Is that dinner time? Breakfast? Not entirely sure. But yes, newborn life is fantastic. We love her so much. All right, variables and assignments. Variables are kind of the building blocks of programming. They are a thing in nearly every programming language, if not every programming language. And variables need values to assign to them. And that's where the assignment part comes in. Variables are just containers or buckets. So if you have a bucket, you might use that for a myriad of different things. You might use it to carry water to wash your car with, or you might use it to carry rocks with, or something like that. But usually a lot of different things can go in that bucket. But it's just a container to hold a value. And with assignment, we are going to put something inside that bucket. And we'll go over specifically how to do that. Variables will typically have unique names, or hopefully have unique names. And with Ruby and with every programming language, there is a specific convention on how to name variables. And Ruby has a specific convention. JavaScript has a convention, and other languages have their own. As we talked about already, the computer doesn't read the variable name and understand it. You might name a variable dog, or you might name it earring or something like that. The computer just sees ones and zeros, and it goes, okay, you named it, a specific set of ones and zeros, that's great. But it can remember that specific set of ones and zeros, and it will remember kind of the address to that specific bucket. Computers are very good at doing one thing over and over again, but they are not good at understanding intent or understanding intent or meaning, I should say. At least not yet. We'll see what happens. So we use variables to make the program faster, describe the information that we are dealing with, and to easily manage our code. Some people say that your variable names should be so descriptive that you don't even need to use comments. I think that's maybe a more advanced topic, but if you describe your variables very well, it will be very easy to understand what your program is doing later on. So how do we get data into these buckets or these containers? Well, we use the assignment operator, which is essentially just a single equal sign. And this is a type of operator, and it sets the right side of the equation equal to the left side. So if we hop over into our Replit, we can delete these things here, and we'll set up our first variable. And we will set this variable equal to dog. Well, we'll name our variable dog. And then we'll use our assignment operator. And then we can name this dog Spot. So what we're doing here is we're declaring a variable, and we're using the assignment operator, and we're going to put the string of spot inside this container of dog. So if we hit enter here, we can then go down here and we can print out our dog variable. We'll see what happens here. And we get the string of spot. So what we're doing right now is we're declaring a variable on line 1, setting it equal to the string of spot, and then we are saying, computer, I would like you to print out the value of whatever is inside the container of dog. And we get the string of spot. We can set up another one, and we will do Ruby Guru. I'll set that equal to the string of Alex Martin. We can come down here to our other line and we'll put Ruby Guru. We get Alex Martin. And we can have as many variables as we want. And they also don't really need to be super descriptive. It doesn't really matter what you name your variables. So I could name my variable dinosaur, and I could set it equal to the string of house. That makes no sense whatsoever, but Ruby is going to understand when I say, give me the value of dinosaur. Oops. It's gonna print house right there. And we'll be doing more things with variables, but that is the very basics of them right now. Here's an example from our website. This is a great diagram of all of the pieces of variable assignment. You've got your name, your assignment operator, and then the string value right there. This is kind of a little extra freebie, not really something that you have to know right now. But there are different scopes in Ruby and in a lot of programming languages where a variable is only available to certain pieces of the code at certain times. So if you want your variable to be available to all of your code at all time, you might want a global variable. And so you might need a $ before your variable name. If you want it only available to a class, you want a double @. And then if you only want it available to a certain instance of your class, you'll want a single @. This is something that's kind of outside the scope of Ruby concepts, but it will be talked about in other Ruby courses. For this class, we'll only be using what's called local scope, and you don't need any kind of symbol before your variable name. I talked a little bit about naming conventions. With Ruby, we do a couple different things. As you saw earlier, I separated multiple words in my Ruby variables with an underscore. And this makes it easier to read. And this is called snake case, I believe. It's been a minute, but snake case Ruby. Actually, I think it might just be called underscore case. Anyways, putting an underscore in between the words in your variable names. Thank you, Alex. That is awesome. You've got your snake case, your kebab cases, and your camel cases. What's recommended for Ruby and Ruby on Rails is snake case. Things that are invalid in Ruby are single letters, and then anything separated with a dash inside Ruby. So if we were to hop in here, instead of Ruby Guru, separate that with a dash, Ruby's gonna yell at us. Go, nope, undefined local method. Basically saying you can't do that. All right. Any questions about variables and assignments? Cool. So as we were going through variables and assignments, I used the term string a lot. And I was pretty specific about, saying exactly what we were doing when we typed Alex Martin. We talked about the string of Alex Martin right here. And a string is a type of data. And it's essentially just words or letters or characters delineated with quotation marks or apostrophes. So anything inside double quotes or single quotes is going to be a string. So that's one of the basic types of data in Ruby. Now, just keep in mind that everything is an object. So everything has methods that you can call on it, and we'll think of that later. But when we talk about different types of data, there are strings, numbers, Booleans. We'll talk about that in a second. Arrays, hashes, and symbols. So what we've been dealing with so far has been just strings. Numbers are just that, just numbers with no quotation marks or anything like that. If you put quotation marks around a number, what's going on here? Set up a new variable, call it number, strings around 42. I guess we have to print it out, don't we? It prints out the string of 42. If we take those quotation marks off of that number, it also prints out the string of, well, it doesn't print out a string of 42, it prints out the number 42. But we will see more how this works in just a moment. So those are numbers. Then we have Booleans, and Booleans are either true or false. There's nothing else, there's no maybe or anything like that. It's just true and false. Arrays, which we'll talk more about, can hold a lot of different other types of data. So we've got numbers in there, we've got strings and a Boolean that are all held within this one array. Hashes are kind of Ruby's version of objects. So if you come from JavaScript and you've dealt with JavaScript objects before, hashes are Ruby's version of that. So we talked about our dog. A dog can have a name, have an age, an owner, and whether or not it's a rescue or not. Then we finally have symbols. And symbols are kind of like the, I believe they are the simplest form of Ruby object. I always have to look this up because I don't use them very often. But yes, a symbol is the most basic Ruby object that you can create. It's just a name and an internal ID. So again, not really used too much, but they can be used in hashes, and we'll go over those a little bit later. But they start with a colon and the key, and then what we call a hash rocket, and then the value. We'll talk about key value pairs in just a bit. So we're going to throw it back to algebra or some kind of high school math here. And we're going to talk about Pemdas. And these are just operators that, that you can use to operate on the data and the data types that we saw in the last slide. A lot of these will be used with numbers. So if you need to do some kind of calculation, these operations are available to you. So if we come over here, back to our replit, and create our new number, 2. We can do operations on these things. So we can do number minus new number, and we should get 32. And again, you can add them together and you can multiply them and all kinds of good stuff there. 420, and then you can do, I believe you can do an exponent, which will give you a giant number there. So if you're really interested in doing math with Ruby, these will be right up your alley. Now, a really fun thing that you can do is you can use math on strings. So if we have a name here, my name, and let's say first name, and my last name in here as well. You can add these two together. And I get a smushed together version of my name, Caleb Mcquade. And this gets back to the idea that computers are very good at following instructions, but they aren't good at following intent. I've told the computer that I want a first name and a last name, and I want them combined, but I want a space in between because that's not a word right there. So what I can do here is I can come into this equation and I can just add a space in between these. And now I get my name with a space in between it. What I've been doing over the past minute or two is called concatenation. And it's the process of combining multiple strings together into one string with that plus operator right there. And that's all it is. It's just concatenation. So if you ever log on and you ever sign into a website and it says, you know, hello, so-and-so, welcome to our website, or something to that effect, happy Thursday, something like that, it's probably using some form of concatenation. What I would guess is it's doing some form of puts, and then there's a string of, wow, can't type today, hello, and then it adds in, you know, name here, and then it kind of finishes out the sentence with welcome to our site. And run this. And it prints out a nice sentence there. And it gives it a little personal feel to the website. But that's just concatenation. Pretty simple, but kind of cool that you can use math operators on different strings. Here's another example, very similar to what we've done already, but you set your first name variable equal to Yukihiro, I believe is how you say that, I could be wrong. And the last name of Matsumoto. You concatenate the two together and you get one word, Yukihiro Matsumoto. But if you put that space in there with the string, you get a nice printed out concatenated string there. Any questions on data types or assignment operators or anything like that?
I'll add one kind of cool bit of trivia. Sometimes I think it's fun to, when you're working with languages like this, kind of try to think like the computer and try to look at it from the computer's perspective and think, okay, you know, I'm a person writing code, but how is the computer interpreting this? And there's something really interesting that I'm just curious if anybody's thinking about here. And that is if we look at that last line, that first name plus, and there's an empty space, and then last name, does Ruby or your computer have any concept of what's inside those variables? Anybody have any guesses?
The quotations possibly have to, the quotations have to designate like if there is a space per se, because if you don't put that in there, it's not realizing what to do.
Yeah, so that's
Okay.
that's a really good call out, Wendy. If we don't have a space there, if we don't have that white space character, which I think we as humans don't really think about as a letter, right? We don't think about the space bar as inserting a letter. But to the computer, that is a unique character. That's just like A, B, 1, 2, 3. That white space character is a unique thing. So we do have to have that there. But Ruby doesn't really know what's inside a string. It knows it's a string. It knows that's its data type. But it can't really tell the difference between the string Yukihiro and the string Matsumoto. They're both just strings. So Caleb mentioned a data type earlier called symbol. And symbol does something really cool to address this. There's an issue we saw in Ruby really early on in the language where every time you create a new string, it makes a new piece of memory to hold that string. And because Ruby doesn't know what's inside the string, it can't say, oh, we're using Caleb over and over again. I'm only going to point at one place in our memory and say, this is Caleb. Anytime I talk about Caleb, grab him from there. I'm going to create hundreds of new references to say, here's a new Caleb, here's a new Caleb, because all I know is it's a new string. So I have to make lots of strings. And during that time, Ruby got a reputation for being a really slow programming language because people would write code that was delightful and easy to read and friendly, and they would use lots of strings. And those lots of strings took up lots and lots of memory. A symbol is Ruby's way of saying, hey, this is a piece of data that I'm going to keep referring to. I don't want you to make new copies of it. I don't want you to make thousands and thousands of the same thing. I'm going to call it a symbol instead of a string. And now whenever I refer to it, you'll know I just go back to that one piece of memory. So the difference there is like if you grabbed a new glass every time you wanted a drink of water in the kitchen, your cabinets would fill up really, really quickly, right? That cup doesn't know what you're putting in it. It just knows you're getting a new cup every time you want a drink. A symbol is the way we say, hey, this is my mug. I'm putting it back in the cabinet. And when I need a mug, I'm going to get that same mug back. And so now instead of needing thousands and thousands of cabinets to support your drinking habit, you just need your one mug. And so that's kind of a cool place where the language being nice and easy to read and useful can also be a detractor. And that goes back to some of what we talked about with different types of programming languages and how some may be stronger for certain use cases than others. Those little idiosyncrasies, right? Those little things that make Ruby unique. whereas a language like, say, Python may already set strings to be comparable. So it doesn't have to create all those things in memory. That might be, that one little difference might be what makes you choose one language over the other. So it can get really technical, but it is fun to think about how's the computer interpreting what I'm telling it versus what did I intend, which goes back to what Caleb said earlier about the computer doesn't know your intent with any of these. You have to tell it, I want this to be a string. I want this to be an object. I want this to be a symbol. Does that make sense to everyone?
That was awesome, Alex. Thank you so much. Cool. Well, we talked about some of the more basic types of data, and now we're going to talk about arrays. And arrays are delineated by square brackets. So if you see square brackets, most of the time, think arrays. But arrays are just lists of items. It's just a way of kind of grouping large amounts of data into one place or one location. So if you have a list of all your customers on your e-commerce site, you might keep all of their names in an array, or all of their IDs in an array, or something like that. If you wanted to send out an email to all of your customers, you might have all of their emails in an array. They just make dealing with large amounts of data easier, and they can contain any type of data. So they can contain strings and numbers and Booleans and even other arrays if we wanted to. So as I said, you can usually spot an array by brackets, and we'll talk about the exception later on. But a quick example is just this one down here where we have our array called fruits, and we have open and close brackets here with strings of bananas, apples, and pears. So if we hop into our replit, we can create a new array. We'll just call it products. And we have a string of earrings. I don't know if that's how you spell that. Earrings and necklaces and rings. If I print this out to our console, sorry everyone, Replit's being a little slow. Products. If we run that, it's just going to print every instance of, or every element inside of our array on separate lines, because we use the puts element. This is a great example for puts versus prints. So we've got everything on its own line, real nice and neat. But with prints, whoops, print, everything just shows up on one line. And that's actually pretty nice too. But there's just that delineation with puts. And we can add in, numbers in here. We can add in Booleans, and we can even add in other arrays of different information. Whoops, forgot a comma there. You do need to use commas to separate each individual element inside your array, just so the computer knows that every single instance is separated by a comma. Let's hop back here. So we can put a lot of things into our array. Sorry, this is Jade. She's a little starved for attention because newborn and all that. But anyways, commercial break. You can put a lot of things into an array, but you probably need to get things out of an array. And so how do we go about doing that? And that's where the idea of indexes in arrays come into play. And arrays are what's called zero index. So when you start counting the elements of the array, you'll want to look at the location of each element inside this array. So if I'm going to go in here and I want earrings out of this array, what I would typically do is I would say, okay, that's the first element. So I would just use square brackets right there. And I say I want the first element out of this array. Instead. But instead of earrings, I get 42, which looks like it's the second element inside my array. And this is where the zero index comes into play. So when you think index, think location, element location. So where is this element in my array? Yes, it is the first element in there, but array indexes start counting at 0. So instead of 1, I use the 0 index of products, I get earrings out there. Does that all make sense? I kind of botched the explanation of that a little bit. So let's say I wanted to get false outside of this array. While it is the third element in my array, remember we start counting from 0. So 0, 1, 2. So if I'm looking for false, I'm going to put 2 inside my brackets there, and I get false. To pull things out of the array, you'll need open and close brackets right next to the name of your array, and then the index of whatever you want out of that array. So if I wanted to pull out this other array of Ruby and JavaScript, I'll go 0, 1, 2, 3. Pull out, oops, 3 there. And I get the array of Ruby JavaScript. Let's see what else we got here. Going back to our fruits array up here, to get bananas out of there, you do fruits, open and close square bracket with 0 in there, which is the first index. Yeah, kind of just reiterating what we've been going through. Does anyone have any questions on that? Alex, you want to say anything more about Booleans and objects versus operator?
Yeah, so Mike had a question in chat about Boolean and what that means. Is it a type of object? Is it an operator? How do we treat that? And I explained a little bit in chat, but just to kind of put a little more detail on there, notice that Boolean doesn't have any quotations around it, just the words true and false. And we really need that in Ruby because we can kind of tie into some of the string stuff we talked about. Ruby doesn't know the difference between the string true and the string false. They're just 2 words, they're strings. Ruby creates a new piece of memory. Remember, you're getting a new cup for each drink every time you use one of those. So we need something that represents actual truth. Is this a real thing? Is it a true thing? Or is it a false thing? Is it a fake thing? Is it something we don't care about? And that's why we have that Boolean data type. behind the scenes, way down inside like the Ruby internals, where you really probably shouldn't be right now, but really never need to go. True and false, the Boolean values are just special internal variables that represent the letters or the numbers 1 and 0. And so when you think about computers being binary, right, they have lots of ones and zeros. That Boolean true and false is as close as you can get to that actual computer speak, because down underneath, those are actual binary values. There's two possibilities, true or false. Does that make sense for everybody?
Yeah, that's a great explanation.
We'll see a little more about how those are used and why that's important when we talk about conditional logic as well.
Yeah, definitely. So arrays are a special data type that come built in with Ruby, and they come built in with a lot of different languages. And Ruby arrays have a lot of different methods that allow you to do different operations on the elements inside the array. And these methods just come built in out of the box for you. So if we hop over to our Ruby documentation here, we'll just Google Ruby array methods. Look here, here we go. So we have a title of methods here, and all of these on this left side here are different methods that do slightly different things. Some of them do very different things. But a lot of these things are very self-explanatory. So we have a method that is just dot reverse. I'm gonna bump this up for everyone here. And all it does is just reverses the order of your array. So if we hop over here and we call our products array, we just say dot reverse with our parentheses on the end. It's going to print out our products array, but just backwards. So that's a pretty simple one. They can get real complex. And then you can even do things to each individual array or each individual element inside the array. With this replace method, it just replaces everything inside that array with a brand new set of elements. So if I just copy this over, just say dot replace, we could get a brand new array with just whatever I put inside of these parentheses here. Just run that. Now I get X, Y, and Z. So there's a lot of really rich and unique things that you can do with Ruby arrays. Let's see if there's anything else here. Yeah. So some of the most basic ones, we looked at reverse already, and you can find out how many things are inside of the array with the dot length property. And you can add things to an array with dot push. And it adds it on to the end of an array. So if I come down here and we're just gonna run this again. So we have our original array here. Let's say I want to add something to this products array. So I say products dot push, and then whatever's inside this open and close parentheses here is going to go right on the end of our products array. So I'm going to push the string of language. If I run that, you can now see that we have language on the end of our products array. Now let's say, you know what, I don't want that anymore. I want to take it off. We can do products.pop with just our open and close parentheses. And that will actually take off the last element of our array and just kind of delete it, throw it into the void. So if I put after this, we're going to put products again. So we have our first array right here. And actually, I'm going to do print instead of puts, so that we can see exactly what's going on. Okay, so we have our first array here, and you can see language is on the end of this array right here. But then on our next array, language is gone because we called that .pop method. Now you might say, you know, sometimes there are things inside the parentheses, sometimes there's nothing inside the parentheses. You put an array in one of the parentheses. How do I know when to put something inside these parentheses? And that's where your documentation is going to come into play. And if you go to these rubydoc.org and other websites like it, Ruby does a great job of giving you an example of how to use these methods. And you can basically just copy and paste and then, you know, plug things in as you need it. As you can see that I did right there. And they give just really good examples that a lot of other languages don't give. Any questions on arrays so far?
I want to call something cool out that's happening here, and you may not even realize it's happening. But Caleb, would you open up your Replit window again?
Absolutely.
I think you still have that code. Yeah, so we can look at this code here. We talked early on about an object-oriented language. What is an object? What does it mean to be an object? And we used examples that were really tangible, right? I used my pen. We talked about dogs or cars. But we're already seeing what it means to be an object-oriented language in the way Caleb's approaching these projects, these examples. Because if we look at products, we're treating products as an object. Products is a thing. We're taking that product's variable and we're saying, I have a products variable. I have an array. I want to push something onto it. I want to interact with it by using these methods. That's what we call those little helpers. I want to pop. I want to take something off the end of this product. So that's what it means to be an object-oriented language, is we're treating even things that aren't representing like a physical object like they're an object. And we're interacting with them almost with like an English language kind of dialect. It's like we're asking a question. Hey, I have a product. I want to push onto it. The alternative to this, the way a language that isn't object-oriented would handle this, would be saying something like push as its own method by itself that accepts both the products array and what you want to put into it. And Caleb, is that something you would mind typing maybe on line 5 there just to compare?
Yeah, sure. So, sorry if this will respond.
No, that's okay. And if it won't come up, I can put it in chat too. I know Replit can be a little slow.
Yeah,
but yeah,
so
if we had push and then in parentheses, we had products, comma, and the string language. This is the way what we would call a functional language, which is kind of the opposite of object-oriented, might approach the same problem. Is they might say, oh, we have a push helper. The push helper takes in 2 arguments and returns something new. It's a little harder to read that, right? It's a little bit of a different way to think about things. And so that's why we said that object-oriented approach is really nice, especially when you're getting started, because it's relatable. You can think about products as a thing that you're interacting with. And you don't have to remember all these extra helper methods that are just kind of floating like that push method is on line 6. So this is a really cool place to start. You know, your brain's starting to form those opinions and you're starting to kind of see these patterns. And it's neat to see those come out in relation to some of the things we've already talked about.
Mike says, how do I retrieve data from deep inside the array without removing it? Great question. So we've actually been doing that while we go along. I'll be super explicit about that. So let's go back to just our products array. We've got earrings, 42, false, et cetera, et cetera. So I'll put products and I'll run that. So Ruby is compiling it all and saying like, here's what's in your products array. Now I can go in here and I can say, I want to get out, let's create a new variable. We're going to call it item. We're going to set it equal to products with the 0 index. So we should get the string of earrings out of this products array. So if I now do puts item, let's run this. So we should print out our products array. It should print out this item, which should be the string of earrings. And that's what I get. Just gonna change this so that it can be super obvious. Okay, so we have our array here, and then we have earrings right here. So I have pulled something out of that array. But if I then go back and say puts products again, as you can see here, earrings is still inside of that products array. So I haven't removed it specifically, but I've pulled out a representation of the 0 index of the products array. And I've set it equal to this variable right here. So I technically haven't removed it from the array, but I'm looking at a representation of what is inside that array at that location. If I wanted to remove something from the array at a specific index, or take out something, I think it's shift here. Remove the first element. Yeah, okay. Yep, okay. So if I wanted to remove an element from the array, I could use the .shift method. So I could call products .shift, and inside my parentheses, I would give it the index of the element that I want to remove from that array. So I could say, I want to remove earrings from it. And now we can look at products again. Okay, so first print products is right here. I've got earrings in there. I take out a representation of the first index, earrings, and I print that. So we have items here. And then I print my products array again. We have earrings all the way down to rings. Why did not? Why did you not work? You guys are seeing debugging in real time here. All right, here we go. We have our products array. We're printing that out to the console. So we print products right here. So we have earrings all the way down through rings. Now I've called shift, which removes the first element outside, the first element in the array. And then I've printed products again. And now we can see in this one, there is no earrings. So that's more of taking out something from the array instead of retrieving something from the array. Does that make sense? Cool. All right. We'll talk about hashes for just a little bit, and then we'll take another break here. So we've talked about objects for a while now. And if you're coming from JavaScript land, JavaScript objects are delineated by curly braces, and they have what's called a key value pair. And a key value pair, it's a set of keys and a set of values. So it's very descriptive, but for me, it's best to look at an example of an object or a hash. So let's hop in here and we will just create our own hash right here. And we're going to create a dog hash. And inside of this, we're going to start with open and close curly braces. And this dog should have a name. We're going to name it Spot. So right here, we have a key value pair. We have a name with a colon, and then we have a value of Spot, the string of Spot. And we can put multiple of these key value pairs inside this hash. So it can have a name, have a color, then it can have whether or not it was a rescue or not. I'm just going to say rescued. And we're going to say true. And that's our Boolean value right there. So it can only be true or false. And this is a hash right here. So if I just hit enter, and if we print out our dog hash, we can see that Ruby reformatted it a little bit, but it's still a hash. And we can make multiple dogs this way in this same idea or the same structure. So I could make another dog. I don't remember that, but let's say make another hash with the same kind of structure. Still have a name. Still have a color. Still have is rescued. And if we run that, we get the same type of thing here. With object-oriented programming, the idea of creating one class or one hash that can kind of be reused over and over again is very common. So if we had a dog hash here that could just be reused every single time, and we could say, my Ruby is a little rough here, rough. We could say, I believe we could do this. Name let's try this. We'll say, we'll call this brand new dog. Let's try that. See what happens here. It didn't like that. That's okay. So essentially, these are items that we can use to store and represent data in very powerful ways. Curly braces are kind of the thing for hashes and for objects. If you see curly braces, think a hash and think key value pairs. Now, I wrote my key value pairs very similar to this way right here. We have our key, and then we have our colon, and then the value, whether that be a string or a number or something like that. But then Ruby, when it printed it out, reformatted it into this format right here. And this is the symbol format that we saw earlier. So it created a symbol with our key with a colon in front of it, and then a hash rocket, and then the value on the back end here. There's a very similar example down here as to what I've been doing over on Replit. So we can store information inside of these, but then how do we get the information out of it? So you take the name of the hash, and then you have to find the corresponding key. So if we come back over here, we have our hash named dog, and I'm gonna in the variable. I see what you're indicating there, Chris. I was trying to do something fancy, and I don't think it's working properly. Again, my Ruby is a bit rusty. All right, we'll come back to that if we have time. Yes, as a constructor, correct. Okay, so we have our dog here, and this is great, but maybe I just want the name of this dog or the color or whether it's rescued. So what I can do here is I can say my hash, and then I'm going to use square brackets again. And as I said earlier, you usually see square brackets and think array. But in this case, we're actually going to be using square brackets to get something out of our hash instead. So we use our square brackets, and then we type in the key for whatever value that we want to get out. So if we want spot out of this hash, we need to find that key of name. We type in name here and run that. We get our hash. And then on the next line, we get the name of our hash dog. And this will work with color as well, and as well as is rescued. So that's how you get elements out of that hash. But again, we're not removing those elements. We're just getting a representation of what is inside that hash. And I do essentially the same thing down here when it comes to retrieving data. Jill says, so is this like creating properties for an object? Yes, this is. So in what we're doing here, we aren't creating properties. We're kind of reading what is on the property for that hash. But what we're doing up here is these are essentially properties for this dog object that we can then call down here. And we can get those elements off of our hash. Any other questions when it comes to hashes? I will say that Ruby does, I'm sorry, SC Codes, the Ruby Concepts course on SC Codes does an amazing job of explaining arrays and hashes in Ruby, probably much better than I have done just now. See if we can hop in here and see what we have. Arrays and hashes. See if there's any nuggets of wisdom that I have missed here. Here's a great little exercise. So this exercise down here gives you a hash, and it's called Grace Hopper. And Grace Hopper was a computer scientist in the very early days of computers, and she was a fantastic woman who really achieved just a lot. But in this hash, we have her full name, her date of birth, occupations, and a list of her achievements. And then also a source from where we got all of this. And to complete the following exercise, use puts to access Grace Hopper's list of achievements. So we have our puts, we have the name of our hash, Grace Hopper. Then we've got our open and close brackets right there. And to get her achievements out of there, we would just find the key achievements, put that colon at the beginning, and just type that out, run that code, and it passed. Fantastic. But it just prints out her list of everything inside that array. Doesn't look like I missed too many nuggets in there. Cool. Any other questions on hashes? Jill says, can you make your own quote unquote properties? Yes. So if I'm understanding correctly, what you're asking is, can you make your own key value pairs? So when you create your hash, you can put whatever key value pairs in there that you want. So I could put, as kind of our absurd example earlier, I could put dinosaur in there and set it equal to the string of house. And that's perfectly valid. It's just going to create that dinosaur house key value pair. As far as adding key value pairs, I believe you can do that with the same the same kind of idea. So let's try this. Got our key, and then we've got our hash rocket here, and we'll set our key equal to the value of golden. And we'll see what happens there. We'll just print out dog. Okay, it didn't work. I wonder if dog breed equals golden. So I was close, but thankfully we've got Alex here to right the ship. So we kind of create a new key on dog with our dog breed here, and then we assign it the value of the string golden. And let's try that. And there it is. So yes, you can create your own properties if you need them. A lot of times people will just kind of redo the original hash that they've started with, rather than create a brand new one like halfway through their code, if that makes sense. So Jill said, I need to think of key values like in a database. So you could, yeah. So if you're going to run like a social media website or something like that, and you need to hold your users in a database, your user will probably be, actually, let's use our dog example here. Let's say you're running a veterinarian service, and you have, your dog objects here, and your dogs can have a variety of different names and colors and breeds and all that good stuff. This could be an example for how your database might look. You might have a column for your name, you might have a column for your color, and so on and so forth. But essentially, this hash right here is unique to Ruby. So it might match up with your database, but it might not. And how you connect those two is kind of up to you. But a lot of times you'll want the two to match between Ruby and database management is a whole nother conversation. But yes, essentially, you might want to think of key value pairs akin to your database. Cool. Any other questions? You all have been awesome on the questions. Really kept me on my toes tonight. So Mike says, what do we use a hash for? So with arrays are used for talking about large amounts of data, and just kind of categorizing and grouping them all together, so that it's easy to go through a long list of items and do a lot of things to each individual item. So think of like large amounts of data with arrays. With hashes, think of going really deep into one specific object, one specific item. So while we might have a lot of dogs in an array, we have one dog in our hash, and we're talking about individual elements on that single dog. So we're talking about its name, its color, and we're going really deep into that one dog. So think of like arrays as lots of data, but not very specific. And then with hashes, think maybe one object and being very specific about that object. And then as Jill said, these can be really good models for storing data and then managing your database over time. Alex, anything else to add there?
No, I think that's really good coverage. We think about these sorts of like more complex data types sometimes in terms of what we call dimensionality, which is kind of a big scary word, but when you break it down, it makes sense. If you have a primitive, so like a number or a string, that's a single dimension of data, right? It's a single point. When we go to an array, we have two-dimensional data because now we have multiple points. So we can kind of draw a line there, right? When we go up to a hash, we have what we would consider to be 3 dimensions of data because now we have multiple keys and we have multiple values. And each of those keys could itself be a hash. So we can nest data in a way that makes a really complex object. And almost every programming language, there's so many of them, I don't ever want to say every language, but almost every one of them creates at least those 3 levels of data. Because when we're communicating, when we're working with code, we very often want to get to at least a key value point. So just like thinking about these as objects and properties, or thinking about them as like a little database, we have a way to retrieve data, which is the key, and we have a value, which represents a data point. And you can describe almost anything in your world using that form of data, right? You can describe yourself, you have an age, you have a height. You can describe I'm looking out my front window, I can describe the tree as it has a type of tree. It has certain colors of leaves and types of bark. And it may have a root system, and that root system may have its own properties. So having this hash style of data is really, really powerful when you start thinking about all the places that just having a key value set let you describe things and let you kind of start to think about how we can interact with things as well.
Thanks, Alex. That's awesome. All right. We are going to take another break here. Kind of missed it a little bit. So how about we all come back in about 7 or 8 minutes? We'll cut it a little bit shorter. So I'll see you back somewhere around 8:21, 8:22, something like that. Alrighty, everyone. We will get started back up again. Before we get too far, just want to say real big thanks to Alex Martin for being on tonight and giving us those awesome nuggets here and there. So big round of applause for Alex. You might be leaving us here in just a couple minutes. But if you ever want to get in touch with Alex, he is on our Slack channel, and we'll talk more about that towards the end of the class. All right, let's get into blocks. So blocks are a bit of a nebulous idea in Ruby, but what I will say about blocks is that they require a couple keywords in them, but they're essentially just an anonymous function. And a function is just a grouping of code where if you put in certain elements, you should expect some certain operations on those elements, and you should get something that comes out the other side. And it's just a chunk of code or a block of code. These may contain an iteration or a conditional, which we'll talk about in just a little bit. But they essentially have a do keyword and an end keyword, but you need both. And Ruby will be sure to tell you if you have missed either one of those. So just an example here. Actually, let's hop into the Ruby code or the Ruby course, because that's where it's all about. All right, so let's copy this iteration right here. Just paste it in there and we'll run it. So what we have here is just a very simple array of the numbers 1, 2, and 3. And then we're calling a method on this array called .each. And then our block is going to be everything from this do keyword to this end keyword. And do and end are what we call reserved words. And reserved words are something that are in several different languages, but they are reserved for the Ruby language, and they mean very specific things. And you can't name variables those reserved words. But essentially, do just indicates, okay, we're starting a block here, and end indicates we are ending the block. But then inside of here, we can do a lot of different operations. We can put a lot of different code inside of this block right here. Essentially, what we're doing here is we are saying for each element inside this array, we're going to take that element and then we're going to print out that element plus 1, and then we're going to end. So for each one of these, we do 1 plus 1, that's 2, 2 plus 1 is 3, 3 plus 1 is 4. So super simple block here, but this is a great example of a block. It's also a great start for our iteration. Before we get into iteration, I want to talk about parameters. Parameters are the pieces of data that we will be passing into the block to kind of be operated on. And you can see that again in this example right here. And you can think of this X right here as each of these numbers. So for every time we iterate through this block, whatever number we are dealing with is going to be the one that we are performing some kind of operation on. And this letter right here doesn't have to be X. It can be anything. It can be number, as long as it corresponds to whatever that number is inside of our block. So parameters are going to be inside of what we call pipes, which is the shift keyword, the shift key and the key above the enter sign. That's where you find your pipe. Cool. So iteration. As I've said before, computers are very good at following instructions, and they can do a lot of the same things over and over and over again, and they don't get tired, and they don't wear down like humans do. With iteration, it makes doing and performing calculations on things very quick, and it saves us a lot of time and energy, essentially. An iteration is a concept that is kind of one of the backbones of computers and the internet. The fact that you can do a lot of things very quickly and the same way every time. It's essentially taking a set of data and doing the same operations to it for each piece of that data. So if I wanted to add a badge to everyone who took this class, what I might do is take an array of all of the students in here. So I could say student 1 and student 2, et cetera, et cetera. And then for my parameter here, I would just call it student. So for each student, what I might want to do is, let's say these are objects. Let's create those objects up here. Student 1 equals, or yeah, hashes. So we'll have name, we'll have Wendy, and then we'll have our badge. We'll just say you don't have a badge yet. So we'll set that equal to false. And then for student 2, on another hash here, and we'll say name Chris. And you also don't have a badge yet, so say false. So now we have an array of both of these objects. And for each of those objects, we're going to take that student. We're going to say student badge. Set that equal to true. So putting that, let's just return that. And then down here, we'll do puts student 1 and puts student 2. So hopefully what I expect should happen would be that both of these badges change from false to true. So let's run this and see what happens. All right, excellent. So it looped through my array right here. And for each of those students, it went in and found the key value pair with the key of badge. And it set it equal to true. So it essentially just changed these badges from false to true. But congratulations, you now have a badge that says that you took the Ruby Concepts course with Caleb. Yeah, so that's a pretty simple iteration. As you saw, we use the .each method for iteration. Other things that you can use are .find or .map. .map is very similar to .each. But if we were to go over here and look at some of these examples. We've got another example dot each there. Dot each. Dot map is a little bit more advanced. It's not terribly advanced though. Yeah, and let's just Google Ruby iteration methods. We'll see what we get here. Yeah, so there's a lot of different types of iterators, and each of them do slightly different things. This collect iterator kind of just collects things together, like it's very similar to the reduce method in JavaScript. Times probably multiplies things, would be my guess. Yeah, so there's just a lot of really cool things that you can do with iterators. But it does use the block format that we saw with the do and the end keywords right there. Another example of this would be just an array of colors right here. And for each of those colors, it just prints out a new line that says current color, and then it prints the color. So you've got some iterators, a block, arrays, parameters, and some concatenation all thrown in there in one. Any questions about blocks or iterators? Cool. Well, congratulations. That is the end of the Ruby Concepts course. You all had some excellent questions and just awesome, thoughtful comments. So thank you all for staying engaged. It makes my job so much easier. Some resources for you as you go forward. If you really loved Ruby and everything that we talked about tonight, I would really recommend either going through the Ruby Concepts course again on SC Codes. It will spell out things in really good detail. And if you feel confident in the concepts that we talked about tonight, moving on to Ruby Basics or Ruby Applications. Code Academy has a Ruby course. That's another great place to learn programming. And then our Slack channel is a great place to get help. If you are interested in getting help from a professional programmer that does this 40 hours a week or more, there is a myriad of different people that live in South Carolina and that are really eager to help learners either get a job or skill up or just learn programming as a hobby. I will attempt to find our Slack channel link. But while I'm doing that, does anyone have any other questions? See, I'm just trying to hack this and see if it works. Nope. That's not what I'm looking for. Where would it be? Sorry, everyone. Okay, here we go. sccodes.slack.com. So I will throw it in the chat in here. Can we use iterators to automate loading arrays? So arrays should load pretty quickly. And you shouldn't have to iterate over anything when it comes to loading arrays. Maybe I'm misunderstanding the question, Mike. But yeah, you can definitely iterate over arrays. That's a big thing that a lot of people do. Thank you all to everyone for coming out tonight. I will stick around to answer any questions, but big thank you to everyone for spending a couple hours with us tonight. Hope to see you on our Slack channel and for other classes in the future. Populate an array. Yes, absolutely. You can use iterators to populate an array. And I mentioned the dot map iterator right here, and that will actually return a new array with different values. So yes, definitely. Thanks, Jill. I will do my best. No promises, though.